Welcome to this Autodesk engineering workflow demonstration. Let's take some time to talk about great technology that is revolutionizing the future of making things. The example we're looking at is a high-performance vehicle made by Briggs Automotive Company. Engineering is challenged to make the car as light as possible for optimal operation. That means reducing mass and experimenting with various materials. Physical prototypes help to ensure lighter components will work, but several generations of making and testing components is time-consuming and expensive. Watch how Autodesk meets these challenges and solves common critical business issues. Autodesk Vault Professional is a great place to start. This is where your engineering data is securely stored and managed. It maintains versions, revisions, and workflows for all documentation. And it is a collaborative environment for designers, engineers, and manufacturing to work together and get the product out the door faster. We know that design is about change. You can see here we have an ECO containing a Nastran analysis that was run after hours on the rocker and the front suspension. And there is an initiative to reduce the weight on the component by 20%. Vault Professional tracks the lifecycle of your engineering data with fully customizable workflows. Let's take a closer look at a report that was created with a click of a button in Nastran InCAD. It comes with the cover page, interactive table of contents, information about the setup, and of course the results. It looks like the existing design for the front rocker is working well, but it is also overbuilt. The viewer works for all types of documentation. Here we can see the Bellcrank before opening it up in Inventor. Autodesk Vault Professional also provides detailed information such as the history of the model, where it's being used, and a complete bill of material. Before creating the new design for the front rocker, we'll create a copy of the existing Bellcrank assembly. Making copies of designs is common, and so is coming up with new part numbers. Autodesk Vault Professional makes this process effortless for the engineer. Part numbering schemes are highly customizable and can be used in the copy design process. Okay, now that we have the Bellcrank open, we'll begin redesigning the front rocker. Let's edit the part in the context of the assembly so we can refer to other components if needed. Here we already have an existing 2D drawing of a lightweight version of the rocker that we can use for the 3D model. All CAD systems, including Inventor, have the ability to draw in 3D. Inventor provides powerful interoperability with DWG underlays in 2016. They are fully functional with the ability to turn on and off layers for clarity. The 2D entities are not just used to create the 3D model, it is also associative. You will see in a few minutes the model will update with changes that are made in AutoCAD. Selection tools are available to decide which entities are going to be used to make the part, and they can be chosen from any view for feature definition. Dimensions can also be used for reference in an extrusion or a parameter. Let's begin adding 3D to our DWG underlay. Once again, the dimensions and other views can be used to define the depth. We're going to start with half the thickness and mirror the body later. Each of the cuts has variable depths, and we can use the same sketch profile to define them. Simply choose the location for the cut and refer to the distance in another view. In an effort to reduce the weight of the part further, we'll create a conical cut on the top and bottom of the design. Inventor understands what you're looking to accomplish without having to finish the sketch or close the profile. Use open profiles such as the one seen here. When executing the cut revolve, it's just a matter of choosing the side that's going to be removed. The power behind using Inventor is its ability to work within the context of the assembly. We have 2 more extrudes to make on the main bore. Defining the depth for each of them is just a matter of selecting the geometry from the other components in the Bellcrank. Inventor provides all the options we need right at our fingertips. Notice we remain in the graphics view the entire time using the marking menu and the heads-up user interface to define each extrusion. And finally, we'll mirror the body for the other half of the rocker. There are hundreds of purchased components that are used in the BAC Mono. Autodesk Inventor contains a massive library of existing components to add to your design from the Content Center. And it's intuitive enough to understand the size components you're looking for based on the geometry you drag it to. This greatly narrows down our search so we can quickly find the configuration we're looking for. Note the Autodesk browser provides great visual feedback on the parts we're currently working on and have changed. Data management is seamless to the user so we can focus on the design instead of file maintenance. The existing assembly drawing is now up to date with a new lightweight version of the rocker. Let's add a parts list to complete the document. The BOM is always up to date, and the ballooning is automatic. The home screen is more than just a great place to access parts and assemblies for current projects. It also provides visual feedback from the vault for the status of each file. You can see the checkbox indicating the assembly we're currently working on is checked out. Now that we have made a copy of the original Bellcrank assembly with the new rocker, it's time to replace it in the chassis. There's a lot of movement in the area of this front suspension. Autodesk Inventor understands the importance of testing dynamic motion with the use of joints. Simply choose the two parts for alignment, and the relationship is complete. We'll do this for all three locations of the front rocker that are attached to other moving components in the suspension. Once the three joints have been applied, we can simply drag and drop the components to make sure everything is working properly. We have successfully remodeled the front rocker with less weight using the existing DWG drawing. The question now is whether the part is going to work. Is it possible it will break, or will the material yield? Let's find out using Autodesk Nastran InCAD. Nastran InCAD is embedded in the Inventor interface and provides powerful FEA capabilities beyond linear static and frequency studies available in Inventor Professional. Let's have a look. Here we not only want to know the stress after the load is applied, we also want to know how long the part will last. First, we'll describe the environment with a few boundary conditions. We'll hold down the part where it's attached to the spring as a worst-case condition. A spring connector would also work to check the displacement. Then we'll use a large force coming from the push rod at 5,000 newtons. The main bore is connected to the frame of the vehicle. There are many ways of constraining models using Nastran InCAD. By adding rigid connectors, we have the flexibility to change the behavior in several ways. Here we'll establish a pin constraint, allowing the Z direction free to move. Now we can mesh the model and run the results. Taking a look at the stress plot, we can see there is a high concentration just beyond the load of 144 megapascals. What does that mean to us? Well, let's find out by comparing the stress to the material we're using in a factor of safety plot. Here our goal is to stay above a value of 2, which is half of the point of failure for this type of aluminum. We're just above 2, which is good, but this was just one load. Will it handle thousands of loads? Let's copy this study and change it to a fatigue study type in order to find out. You can see in this pull down, there are several powerful ways to validate your design, such as linear and nonlinear, frequency, fatigue, vibration, and thermal heat transfer, to name a few. There are only a couple items to add to the fatigue study. What is the behavior of the load? Is it loaded and unloaded? Is it fully reversed in both directions? Use the table to create any loading condition that matches the real-world scenario. Also change the way the results are displayed. Convert the number of loads to time, like months or years, or in this case to the number of times it can be used on a track during a given day. This way the value that is produced in the results would be more meaningful. After running the study, we can see the part is going to last for 8.5 uses, which is not long enough unless we want to replace the part at least once a year. Let's make a few changes to the design right here in Inventor. Watch as we add additional geometry with the results on the screen, which aids in making informed design decisions. We'll add some more material to the center of the pocket and apply a few fillets for manufacturing. While we're changing the model here in Inventor, let's explore modifications that come from the AutoCAD drawing as well. Have you ever seen a 2D AutoCAD drawing update the 3D model? Well, Inventor 2016 has made this possible. Let's move the rib up 10 millimeters and save the file. Back in Inventor, it's just a rebuild button click away. Now we can update the mesh and rerun the study. First, we want to know if the part is going to last longer with the recent change. We can see right away that the life of the part is infinite, and the stress level is lower at less than 100 megapascals. Autodesk Nastran InCAD took us beyond the capabilities of linear static studies to ensure that our new front rocker design is ready for manufacturing. It's also important to communicate modifications we've made to other team members during check-in. Autodesk Vault not only documents comments for each version, it also maintains previous versions of the model to visualize the change or to roll back if necessary. Back in the assembly, we can see the updated components in the front suspension. Let's add a final note during check-in of the chassis for the ECO we responded to earlier. We have successfully redesigned the front rocker utilizing existing DWG data and the powerful analysis capabilities in Nastran InCAD. As you have seen, Autodesk offers integrated solutions to get the job done faster. Design, validate, and manage all within the familiar Inventor interface. Autodesk is your trusted solution for the future of making things.